I really appreciate that I have the opportunity to talk today here in front of you. Normally I speak at international conferences and every single word is learned from the beginning, and I have test talks beforehand in front of my colleagues, and this presentation now is totally spontaneous. I hope you like it. And before I start, I would just introduce myself a little bit and talk about personal things. And yes, that's true. But I think there are some positive aspects about it. What I like about being single is you have a lot of space in your bed. Only the doctor can tell you what to eat. Maybe some of you might already know this could be a problem in a relationship. You care more of your friends. You are outgoing when you are single. You want to get to know new people. And look at them. They are looking like very happy people, and they are all singles, but they don't look like really, really sad. This beer drinking, forget about it. But when you have a look at this picture and the following ones, it is kind of sad that I went to all these amazing places and there's no one surrounding me, coming with me, and
who took the pictures?
Yeah, okay. My ex-girlfriend. So there are definitely also some negative aspects about being single, and therefore we have this very lovely woman. She is taking care of all of us. She is responsible for family affairs in the German government, and she really knows what she's doing. She is only 35 years old and already minister in the German government, and she got pregnant during her regency. And what she is trying to do is to bring the single people into family life. And now there's a tremendous situation here in Germany. You all know that we have a problem with our Nachwuchs. There are less children being born in Germany, and therefore Christina is very sad. And now, when she has the power to do something, she's putting a lot of money into the system. Maybe you heard about it in the news. There was 2 weeks ago something about it. We actually spent in Germany 200 billion euros per year for family affairs. And maybe these are a lot of zeros, and I couldn't really imagine what this means. It was just a big number for me, and therefore I made some Gedankenexperiment. I think it's also an English word. Yeah, and I thought, how many of those next coming Miroslav Kloses or Lukas Podolskis or I don't know will be born in every year in Germany, and there are 600,000 babies, and now I wanted to express this amount of money in the number of babies and divided them, and what you see is we spend for every child here in Germany 300,000 euros. Now, if the government would tell me, well, if you make a baby, or maybe the woman, of course, but and you will get 300,000 euros, then we should definitely exchange numbers. And that was amazing to me to calculate this. But now you might ask, what has all this to do with my PhD thesis? And yeah, I'm working in the field of solar cells, and I was talking all the time about family affairs. But I think there's a strong relationship. But to understand this, I would just review some parts of the concepts of the solar cell. So when this light shines onto the solar cell, we have a plus and a minus voltage at the contacts, and now we connect the solar cell with some kind of power demand, like a lamp, and when we do this, a current flows and the lamp will shine. So this is the very basic concept of the solar cell. Now let's look into a bit more detail what this is all about. The solar cell is made of silicon, and in silicon we have electrons surrounding the nucleus in this atom. And now when the sun, this was planned, of course. No, you see, this is like a little family here. They are sticking around together, and this is an atom, and you know, this is kind of a partnership and couple. And now the sun will shine onto this atom, and one of the electrons will get hit and escapes this kind of partnership, and then this potential will develop, and this gives us the energy in the solar cell. So we actually want them to split. So we physicists want to break up partnerships, and this is what will result. Yeah, how do we understand this on a micro scale? So we build up a crystal of silicon atoms, so put them nicely together, very ordered. And then we have electrons surrounding them, free electrons, but they are bonded in between the atoms. And there basically nothing happens. If you put a charged particle inside, it will move around, but nothing will happen. Everything is very... No, nothing will happen. But when you have a look at the surfaces, these regions here, when this silicon crystal is ending and there are no more silicon atoms, and we have single electrons here, and when we have this situation, when the charged particle may move there and recombine, and we will lose all the energy. So we need to have a border here. We don't want this charged particle to get here, and therefore we introduce this potential barrier. And how do we do this? We actually change a little bit the design of the solar cell, and then the charged particle cannot go through this potential barrier, and we save the energy, and we can use it for the lamp. And how do we actually do this? So this is the sketch of the special type of silicon solar cell that we are doing research on. And if you have a look with a scanning electron microscope onto this contacts here, it looks like this. Actually, we have to rotate the solar cell so that these two will match. And what you see here is when the metal on top of the solar cell, and here's the silicon, and here you have these nice contacts. And what you can see here already is that there are some nice features depending on, for example, the thickness of the aluminum here. And if you put less aluminum on top of the contact, also the contact size will decrease, and also the diff. So this is actually what is kind of nice about my research, that you have some geometrics involved into this contact formation. And these little gray features here are actually the potential barriers, which help to prevent that the charged particles will recombine. And another picture here. Very quickly. So you see here now, instead of instead of different thicknesses, we can also vary the geometry, make the contact a little wider, and it looks very different. And then we can also make point contacts like this here, a rectangle, and then we get very different contact structures without these light gray structures. And if we make the points even smaller, then another structure will develop. So this is very basically my PhD work. And let's get back then to the solar cell concept. We had this structure here, everything works fine, the potential barrier exists, and everything good. But if we have these points, the potential barrier is very thin, and then it will vanish, and then the charged particles will recombine there, and we will get serious problems. And yeah, that's basically it. So coming from splitting up partnerships in physics, we get electrons and holes to travel around the circuit, and when they go to the lamp and they finally find together and light will shine, that's it.